So coming on to the integer type problems, we have question number 58, which says that consider a function fx is equal to greatest integer of sin x plus greatest integer of cos x in the number of points belonging to its domain and lying in the interval minus 2 pi to 2 pi where the function is not differentiable is. So students, what we have to do in this type of problems, we have to draw the graph of sin x, cos x, and then we have to analyze in each of the quadrants what will be the behavior of greatest integer of sin x as well as the greatest integer of cos x, paying special attention at the endpoints of every interval, that is pi by 2, pi, 3 pi by 2, 2 pi, 0 and so on. So over here we have an open interval of minus 2 pi to 2 pi. What we will do, we will analyze this particular function in one complete cycle, that is 0 to 2 pi, and double of that will be my answer. Okay, so let us have the graphs on board. The green graph is of sin x, the orange graph is of cos x. Over here in the lower portion I am going to draw y equals fx. So talking about the first quadrant, both the values lying are positive, lying between 0 to 1. Greatest integer of sin x 0, greatest integer of cos x 0, whole value is 0. Starting with open circle over here until pi by 2 it is 0. At 0, obviously the value of the function is 1. 1. At pi by 2 again it is 1. Talking about the second quadrant, sin is positive, greatest integer is 0, cos is negative, greatest integer is minus 1. So the values are minus 1 till pi. At pi, again the value is minus 1, so we have a closed interval here. Then, talking in the third quadrant, both the values are minus 1, so the final answer will be minus 2. So this is minus 1, this is minus 2. At x equal to 3 pi by 2, again, the value is 0 and minus 1, so it is minus 1 again, 3 pi by 2. Talking in the fourth quadrant, sin x is negative, so minus 1, cos x is positive, so 0, minus 1. And we don't have to consider the endpoint 2 pi, so it is fine. So the number of points with the function is non-differentiable. Everywhere the function is discontinuous, it has to be non-differentiable. So what are the points of non-differentiability? X equal to 0, pi by 2, pi and 3 pi by 2. Students, pay careful attention. These 3 points will be repeated on the negative side of the interval, that is minus 2 pi to 0. So 3 into 2 plus 1. Total answer for points of non-differentiability will be 7. So final answer for this particular question is 7. Okay, let us move on to 59. Question number 59 says that consider 3 unit vectors a vector, b vector and c vector such that a cross b cross c is b vector by 2 plus c vector and a cross b cross c is non-zero, is not equal to 0 vector. If the angle between b vector and c vector is x degrees, then what is the value of x by 15? So let us simplify this particular vector triple product and compare the coefficients on both the sides. So we have a dot c b vector minus a dot b c vector is equal to b vector by 2 plus c vector. So what do we have? A dot c is equal to half and a dot b equal to minus 1. So if a dot b is minus 1, angle between a vector and b vector is 180 degree. Angle between a vector and b vector is 180 degree because cos of alpha is equal to minus 1. A and b are unit vectors over there. So a and b vector are something like this, originating from a single point but running in opposite directions. A vector, b vector. Then a dot c is equal to half, so angle between a vector and c vector is 60 degree. So c vector is something like this. C vector. This particular angle is 60 degree. Again, given both are unit vectors. What is the angle between b vector and c vector? Very simple, 120 degrees. So we have x as 120. So therefore, x by 15 will be equal to 8. So we have 8 as the final answer of this question. Okay, let us move on to the last question of this exam now. Question number 60 says that if the points 1, 1, 1, 2, 2, 2, lambda 1 minus 1 and 1 lambda 2 are coplanar, then sum of all possible values of lambda is a point 1, 1, 1, b point 2, 2, 2, c point lambda 1 minus 1 and d point 1 lambda 2 are coplanar. So we have the scalar triple product of b vector minus a vector, c vector minus a vector, d vector minus a vector equal to 0 because these 3 vectors will be coplanar now. So we have 1, 1, 1, that is 2 minus 1, 2 minus 1, 2 minus 1. lambda minus 1, 0 minus 2, and 0, lambda minus 1 and 1 equals to 0. Solving this particular determinant, we'll get lambda square minus lambda equals 0. That is lambda into lambda minus 1 equals to 0. Either lambda is 0 or lambda is 1. So we have sum of all possible values of lambda equal to unity. Okay, this is the final answer. And with this, we come to the end of discussion of this particular exam. I hope you have understood all the questions clearly. We'll see you further in the discussion of paper 2. Thank you very much.